Hi there, my name's Andy. This is the very start of my journey in modular synthesis. I've started with basically the eurorack. I've built a little case and I'm going to start things rolling with an actual power supply. So I'm a computer engineer by trade, but that doesn't mean soldering or anything like that. I'm just good with cables and that kind of stuff. So I know how to solder. I've fixed other stuff before, generally like broken wire connectors and stuff like that, but this journey of soldering and modular synthesis and all that's involved is a new journey for me. I've been involved in radio controlled helicopters and planes and stuff like that before, so I'm not a stranger to soldering iron, but I'm in no way an expert. We all learn through YouTube videos, and that's how I've learned. So I'm just kind of giving back as well as recording my own experience so I can learn also from my mistakes, obviously, and there will probably be many. We're starting with a very basic power supply, really. It's the frequency central microbus. I actually kind of got the heads up on this one via Look Mum No Computer. I'll put a link to Sam's channel in this because everything I've seen so far is great. He's got the great attitude and he's really into getting his hands dirty, which is what I'm kind of about, really. I aim to kind of learn from my experience of building this stuff, making mistakes and just trying to work it out, like the rest of you. I am a computer engineer, but it's a lot different than this kind of stuff. We don't solder and we don't mess around with components. Yeah, should we get stuck in then? So basically I started off by buying the PCB. I didn't get a kit with all the components. All the components I bought separate. So yeah, let's have a rundown of all the components, shall we? So starting off, we've got the frequency central microbus, which you can grab online. That's the front of the board and that's the back of the board. You can pick that up online, just Google it. It's nice and cheap. I think you can get it as a kit with all the components as well, but I just grabbed the PCB. So to start things, we start with the big caps. So they're 4700 UF 25 volt caps, 6 of those. We've also got 3 100 UF 35 volt capacitors, and yeah, the 7912 and also the 7812. Some heat sinks I bought separate and some screws. Also, I'm going to be using 2 products. I'm going to use a heat paste between the surfaces and also a thread lock in the heat sinks with the screws. Main reason for both of these, one obviously to transfer heat from one unit to another, but also the thread lock stops this screw unscrewing over what they call heat creep. So you've got to bear in mind these things get hot and then they cool down, they get hot and cool down. That introduces what's called heat creep, and screws and bolts and nuts and stuff like that can slowly undo themselves over time. So the thread lock hopefully just stops that. Again, the thread lock is from the radio control world. We use it everywhere on a helicopter. So yeah, next on the build list we've got diodes. These are 1N4004 and we've got 6 of those. Then we've got the resistors. Now, the resistors here are not exactly like photographs on the frequency central build PDF of 5-band resistors. And I have, in my naive range of knowledge, I've checked them out. The same resistance, and they should work as far as I'm concerned, as far as I've looked. But I might be wrong, and this might all go wrong. Anyway, so they're the 1K resistors. As you can see there, on those ones, they're, I think, brown, black, red, gold. Whereas on the 5-band, which is in the photo at the build PDF, they're brown, black, black, brown, brown. Slight difference in tolerance, and I'm hoping that that won't cause a problem with the build. So that's the resistors. Next, actually 2 capacitors, and as far as I'm aware, they're not polarized, so it doesn't matter which way round you solder them in. These are the 104J100s, yeah, 2 of them. And then we move on to the voltage regulator, 78L05. Also some power headers cut down, 8 pins either side, so 16 pins, 8 of those. And lastly, a cable going into the PCB for 12 volts AC, not DC. So for this, because I plan it to be removable from my case, which I've just finished building, Sadly, I didn't do a video. The cable end is going to go into the PCB. The other end is going to go into a socket, which will then incorporate it into the case for the external wall watt, which I think is how you pronounce it. Actually, you can see the PCB mounts within the case, those 3 pins, and the hole there, glue an aluminium plate DC socket that matches the wall adapter that I bought, which, yeah, it has to be AC, 12 volt AC. But yeah, that's the case I worked together. There you can see me plugged into it on the aluminium plate. It's all glued in. And I think on the next slide you can see internally, and then there's the female adapter for the cable that I've started with. So I've already double checked all the components, ignoring the input barrel there, because that's going to go in line in the cable now. The only thing missing is the LEDs. I've got the LEDs as well, but I'm going to go different colours. So I'm going to have 12 volt minus, I'm going to probably do red, 12 volt plus I'm going to do green, and the 5 volt plus I'm probably going to use blue, just to differentiate between them. The guide I'm using is obviously the PDF that's provided with the kit, or also the PCB. So where are we going to start? I've heard the smallest components are the best place to start, so I'm going to put aside a whole load of this lot and start with the small components. Also, like I said, with these heat sinks, I'm going to use some thermal paste. What you'd normally use in my world with a processor, old school processor, and you want to put a heat sink on, that's what you're going to clamp down on the top, and what you're going to put down in between the CPU and the heat sink. So basically, conductive paste will just take the heat and transfer it to the heatsink, which is what it's designed to do. So we're going to start with the smallest components. I'm thinking probably the diodes first. The diodes, because these particular diodes, they've got thicker legs on them, so they're quite difficult to put in place sometimes. Now with the diodes, obviously they're in one direction, or polarized, I think that's the correct term. And as far as this build's concerned, we got the connection here. So for these, we're going to be a line pointing up. So it's just a case of getting these to fit the gap in the PCB. So that looks good enough for me. And I'm double checking with some of the pictures, the guide, PDF guide. You can clearly see the polarity of the diodes. You might notice the components I'm using have got pretty bent up legs already. That's where I've been double checking everything and making sure everything fits okay. So where else do we need the diodes? We've got one there. At the top, just make sure they're all the same polarity. We get them right way round. Now, where's the last one? There's one just in front of the LED, and one just to the side. So you want these quite tight to the PCB, so just holding them down, pulling the legs open. And then we can just solder them in place. Right. So next, some solder. Now, I'm no expert at soldering, so I'll try my best. And the soldering iron I'm using is quite cheap, so I'm going to double check this, make sure it's all looking good. In fact, just grab my one real good tool, a jeweler's loop. You can really see quite close how good the solder is. I'm not sure if I can do this, but you never know. Yeah, you can see that quite well. So you can see it's soldered well. A quick look by eye. Yeah, that's perfect. So I'm not 100% sure about soldering iron temperature and stuff like that, and I've got a variable temperature, but it's only a cheap soldering iron from like eBay. But my main purpose is to keep soldering quite light, not too much solder, just enough to hold it all in place. But you know, no big mess. And always have a good look through a jeweler's loop to see how well, you know, it's all taken. I'm no expert at soldering, but I know that, you know, it has to basically drop. All temperatures need to be high enough for the solder to take to the pad or the trace and the component as well. I've got a kind of DIY fan going on here for trying to get rid of the solder fumes in the window open as well. But, you know, I might invest into a proper extractor fan and filter. Just stick a big tube out the window. But for now, this is a occasional kind of thing for me rather than every day. Well, at the moment. That one just taking a little bit to take. So is that all of them? I think so. I'm just going to give that a quick once over by jeweler's loop. Make sure they're all looking good. Neat. Yeah, they're all looking really good. Nothing's loose. Yeah, they feel good to me. So, something to cut with. I actually started just using nail clippers because you can you get a nice close sharp cut. Keep everything nice and neat. You might see a few battle scars on my hands from making the eurorack case, actually. Not too sure about that one. I might give that one a little another touch. better to me. Right. So I think that's probably the stage one's the diodes. Let's move on to the resistors. Right. Again, just shaping them down a bit. It's actually quite tight on this board. So we've got one there. Again, trying to keep things kind of neat. I like to, I know some people swear by damp sponges, and I've got a little dish of old steel wool that I dip into every now and again. But I actually prefer a damp cotton. What I'm using right now is like a damp cotton lump of material that's just add a little bit of water, wring it out. You can roll the iron in it and actually clean it quite well. But who am I to? I'm fairly new to all of this, but it just seems to work for me. I'm not quite sure if that's the way, but I do have a fan pulling the fumes away from the board. I just jump. No, that's right. So I think the idea with soldering is you heat the component and the pad and then apply the solder. The solder follows the heat. So wherever the heat is, it will follow. So if you make the component and the pad or the trace hot, the solder will naturally go to it and adhere, what we like to call drop. Can't really see it. Oh, actually, you can. Next up, we're going to put the 78L05, which is a little voltage regulator. Hopefully I can show you why I look. See that? You can see that there's a little air bubble at the bottom one, or a little hole, but you can kind of see it's dropped and taken. The middle one's got a bit of a, not quite sure about that. I'm going to check that again. No, that's all right. As long as it's like, you know, it's taken all the way around the leg and it's all nice and even. It's all good. Hopefully you can kind of see that. Right. Move on to the next bits. Right, next we've got the, now I think these are not non-polarized capacitors. They're the 104J100s. So let's put the smaller capacitors in. So with the polarity of these, they are polarized. So we want the negative facing down. So the square is positive. So next, let's look at the voltage regulators. Now for these, we need heat sinks. And for this, I'm going to use two substances. One to transfer heat from the voltage regulator over to the heatsink, and another to stop the screw undoing. So first of all, I'm going to put a tiny little dollop in the middle there. Just use a cocktail stick or something like that. Get a little bit of thread lock, whether it's blue, green or red. Blue is like a semi-permanent lock. I think green is a bit more harsh. And red I think is like a permanent glue basically. So you just want to, my idea of what should happen is you should have a little bit of thread lock in there to stop creep from the temperature change. Where do these go? Which one's which? That's the 7812. So the 7812 goes there, that way round, and the 7912, double check, 7912, it goes that way round. Now, I want to keep these nice and stable on the board. Just hold them flat to the board and spread the legs out a bit. Just put something under there while I'm soldering it. Keep them flat. Make sure that there's no bridges at all. So you can see that. So Next, and pretty much last, we've got the large capacitors. So next we got the power supply, which is AC, so it doesn't actually matter which way round. And I've got a connector that's slightly different than standard. I'm going straight into the board. Right, so all we need now is LEDs. Right, so we have some LEDs. We need 3. So let's start with a red LED, and that is on the minus 12 volt. Now, if I remember the instructions, polarity is indicated by a square cathode. So there's a square cathode, which is actually negative. We want the anode for the long leg. So that's the minus 12 done. Open them legs out, hold it in place for a sec. Now for the plus 12, I'm going to be using green. And that we're going to use over here. And just fold them out of the way. And for the plus 5, let's use blue. So blue for plus 5. I'm not entirely sure if I need plus 5 yet. So cathode is square. My understanding, plus 5 is generally for digital modules as opposed to analog modules. Right, so let's solder them in. Right, so that's all the LEDs done. Let's test the little project so far. I've connected it through the thing I explained earlier. Basically, it's a jack in the back of the case that goes into an AC power wallet or converter, but yeah, it's AC. Oh wow, it's working. So we've got the red LED on the back, on the left hand side, which is minus 12 volts. We've got a green LED bottom right, which is plus 12 volts, and we've got a blue LED for plus 5 volts. Oh, all looking good so far. The LEDs are correct, so all I need to do is test the pin outlets. The reason why I've left them without no headers is so I can put the probes from the multimeter in nice and easily and securely, and I don't short anything. You know, it's nice and easy with pins. So I shall test the buses or the rails, make sure everything's according to how it should be in a modular eurorack modular. I've got the pin outs for that, so I'll test that, and then yeah, wow, brilliant, it's working. I'm quite surprised actually. It's all good. Right, so the final test is to test the rails. Pin 1 is minus 12 volts. Actually, one thing I have noticed, if you look on the back, there's only traces on pin 1 and 2, 9, 10, 11 and 12. So, probably easier to turn it over. So, pin 1 is down towards the bottom edge. Pin 1 is minus 12. Yeah. Take a standard ground, which is at pins 3 and 4. We'll take a ground from 3 and 4. So first of all, we're looking for minus 12. That's close enough for me. Minus 11.95. Then I think the next row is the plus 12. So we've got 12.08. And the next row is the plus 5, which we're at 5.05. So that looks great to me. Bloody hell, it works.